All right, calculus, welcome to a section 3.1 video here, talking about some now rules for differentiation. All right, so I made a quick video, about 7 minutes, to show you how we get the power rule. All right, we did our last one with the limit definition of the derivative. So let's take a look at example 1. Differentiates. First off, this is x to the first. The derivative of any constant is 0. Bring down that 1 times a negative 2/3. Again, this is f prime of x, which is going to be negative 2/3. Because you'd be left with negative 2/3 x to the 1 power less, and x to the 0 power is just 1. Not 0, it's 1. That's why I get a negative 2/3. All right, so using a different stand here, hopefully less shaky. Here you guys don't know the product rule. This would not be a good one to use the product rule for. So on some of them in your homework set, you are going to have to distribute. Now this is just f of x, so don't stop here. F prime of x would be 2x, bring the power down, 1 power less, minus 6x squared, and that is it. All right. So these are polynomials that we're talking about here. These are going to be, this is a very easy section. All right. We'll get into the more fancy ones early next week. Example 3. So f of x is this. So f prime of x, bring down the power. That is a negative 6/4. We'll reduce that in a second. 1 power less, you're going to subtract 4/4, so that's negative 7/4. So this is a negative 3/2 x to the negative 7/4. You know, some places might not want to see that negative exponent, you can also say negative 3/2 x to the 7/4. That's also good. All right, on number 4 here, we do not know the chain rule yet. Inner product is 6x, double it, plus 4. So that is f of x. So f prime of x is 18x plus 12. Again, the derivative of 4, that constant is 0. On 5, what we're going to do here is, again, this is x to the 1/2. That's being multiplied by x to the first and 1. So y is going to be now x to the 3/2 minus x to the 1/2. And again, you know, y, same thing as f of x. So when I, look for f prime of x or y prime or dy dx, I'm really talking about the same thing here. Okay, so y prime would be 3/2 x to the 1 power less minus, bring the power down, 1 power less. Some of us working with those fractional exponents is what's going to take the most work. Again, it's all about that algebra. It's all about that algebra. Got to be good at it. So if we wanted to, we could call this 3/2 times root x minus 1/2 root x, because x to the negative 1/2 would be 1/x to the 1/2, which would be the square root of x. All right, let's take a look at number 6 here. Going to divide by root x, so this is really saying 4x squared plus 5x minus 8 divided by x to the 1/2. So all of these powers are going to lose 1/2 power, lose 1/2 in regards to x there. So it's going to be 4x to the 3/2 plus 5x to the 1/2 minus 8x to the negative 1/2. Too often I see students write like a minus 8 minus x to the 1/2 because they're like, oh, I need to subtract 1/2 power. I'm going to leave it as negative 8 though. I see that error too much. Okay, this is really like saying x to the 0. So if you subtract 1/2 from 0, you got negative 1/2. All right. Bring down the power. 4/3 times, 3/2 times 4 is 12/2, which is 6. X to the 1 power less plus 5/2 x to the 1 power less. Negative times a negative is a positive 1 power less. Okay, we didn't see any negative exponents, so that's kind of my rule of thumb. So it's going to be plus 5 over 2x to the 1/2 plus 4 over x to the 3/2. Now this would be, make sure you write this out for me. That is f prime of x. That is the derivative. Okay? Great. Let's keep going here. This is just to know now for a lot of these I will, we'll prove, that the derivative of sine x is blank, that the derivative of cosine is blank, that the derivative of tangent and secant is blank, all right? This one you show more graphically why it's the case, but the derivative of e to the x is just e to the x. Now, if there's like a 2x there or an x squared, using the chain rule, we'll see how this gets a little more interesting. But if I just have e to the x, it's simply, the derivative is simply e to the x. So just write that down. We'll do more sophisticated things with it when we talk about the chain rule. All right, find an equation of the tangent line to the curve at the given point. Folks, the derivative, you were using a derivative definition when we did this last chapter. Now, we handled things to the third power, but not to the fourth. Okay, we had to use synthetic division. So what we were evaluating is we were finding the derivative and evaluating it at x equals 1 each time. All right, so what we're going to do is we're going to find y prime, and that's going to be 4x to the third plus 4x minus 1. So the slope is the derivative evaluated at x equals 1. Again, y prime is the derivative. It's like saying f prime of x. So I simply plug 1 in for x, and my slope is 7. Wow, that's quick now. So y minus the y value is equal to the slope times x minus the x value. Again, the equation of the tangent line has a slope that is the derivative of that curve evaluated at that x value. All right, so y prime is 6x minus 3x squared. So the slope would be the derivative evaluated at 1. The slope is 3. So y minus the y value is equal to the slope times x minus the x value. Example 9. So first off, you're going to want to say that this is x to the 1/2. Or I'm sorry, 1/4. So y prime would be bring down the power 1 power less. So really, if you want to evaluate this, which you do, you want to write it like that. Now, dealing with 1's pretty easy. So the slope is going to be this derivative evaluated at 1. Again, y prime, same thing as f prime of x. So I'm going to plug 1 in for x, which is going to give me 1/4. So y minus the y value is equal to the slope times x minus the x value. So you got plenty of those, and some might be a little bit more challenging on your homework, but at least you can get started, a good start on that. Let's talk about number 10 here. Find the first and the second derivative. We'll talk about the first and second derivative, I think, on example 12, which we'll conclude with here. So the first derivative would be this. Bring down the power, that is going to be 18 over 2, so 9x to the 1/2 minus, bring down the power, 1 power less. That's the first derivative, easy peasy. The second derivative, f double prime of x. Bring down the power, 9/2, 1 power less, minus 80x to the third. So what do you have? You have f double prime of x is equal to 9 over 2 root x minus 80x to the third. So do write your answers kind of like that on your homework. X to the negative 1/2 puts x to the 1/2 in the denominator. That's the square root of x. All right, number 11. Here is now a pretty easy one for us. So suppose that the height of an object t seconds after being launched from an initial height of 25 feet is given by that. We did this a lot. This was on your exam. It's a hard one to find the instantaneous velocity using the limit definition. But now, folks, so given the position function, which is either like s of t or h of t, the velocity is the derivative of the position function. And we saw that because we were using a limit definition of a derivative. So first off, my velocity function would be negative 32t plus 68t. Not t plus 68. I made a boo-boo there. Get rid of this t. Just the derivative of the position function. Okay, so this is awesome. So now, if I want to find the instantaneous velocity at time t equals 1, again, you have to show that to me somewhere in this problem. So the velocity at time t equals 1, see, this is how it was so quick for me to check your answers when we did this, even though it took a lot of work. Now we're talking about 36 feet per second. We find the velocity function, and we simply plug 1 in for t. Yes, it is that easy. I know it is aggravating to do all that limit definition work and then be shown, hey, this is how we can also do it. So the limit, or velocity at 2.5 seconds is this velocity function, which is the derivative of the position function. We evaluated at 2.5, so now it's fallen down, negative 12 feet per second. This becomes a very easy question. Lastly, let's talk about velocity and acceleration, okay? So the equation of motion of a particle is given by that, where s is in meters and t is in seconds. Find the velocity and acceleration as functions of t. Well, velocity is the derivative of the position function, so take that position function and differentiate it, find the derivative. There you go. And acceleration is the second derivative of the position function, or so I can write acceleration is the second derivative of the position function, or acceleration is the derivative of velocity. So I'm just going to look at velocity. I'm going to take its derivative. There we go. Find the acceleration after 1.5 seconds. So 1.5, plug it in here. 12 times, I think, 2.25 minus 27 plus 10. Oh, I think this is actually going to be 10. What is that, 10 meters per second squared? Acceleration, you should know this. Yeah. All right. Yeah. Meters per second squared. Cool, great, there it is, and that is it for section 3.1, I believe. All right, well, next one we'll cover some trig definitions and so forth, maybe even product and quotient rule. This is Yak Math Videos signing out.